Hey everyone, and welcome. Ever scroll through your grades and wonder what your real average is? Or look at your friends' streaming playlists and try to figure out what the most popular song is? Or how about this? You check the weather and it says the average temperature is 20 degrees, but one day it's 40 and the next day it's 0. That average doesn't really tell you the whole story, does it? All of that's data, but just having a mountain of data is useless. It's just numbers. Our mission today is to become data detective. We're going to learn the secret codes to understand what all those numbers are really trying to tell us. Welcome to our mission, Descriptive Statistics. Now, I know what you're thinking. Statistics sounds boring, but I promise you, this is a superpower. This is how you take a chaotic mess of numbers and turn it into simple, powerful understanding. We're going to explore key concepts like mean, median, mode, variance, and standard deviation. And we'll use awesome visuals and real-world examples to make it all click. Let's get started. So what are descriptive statistics? Think of it like this. You just got a 1,000-piece jigsaw puzzle. Descriptive statistics are the tools that let you flip all the pieces over, find all the edge pieces, and sort them by color. It's not about predicting the future, it's about making sense of the chaos you have right now. We're going to learn how to summarize a giant pile of data into 1 or 2 meaningful numbers. Identify patterns, like, hey, why does this keep happening? Make comparisons to see how things stack up, and finally, visualize it, turning boring spreadsheets into charts that tell a story at a single glance. We'll be focusing on 2 main types of tools, measures of central tendency and measures of dispersion. Let's dive into the first one. All right, first up, measures of central tendency. This is a super fancy phrase for a really simple idea, finding the center of your data. What's the typical value? What's the middle ground? And we have 3 main tools, our big 3 for this: the mean, the median, and the mode. And here's the key insight. They each tell a different story about your data. Choosing the right one is like choosing the right filter for your photo. It can change everything. Let's meet them one by one. First up, the one you already know and love, the mean. This is just the good old-fashioned average. You've been calculating this forever. You just add up all the values and then divide by the number of values you have. Look at the example. 10, 12, 14, 16, 18. Add them up. You get 70. Divide by the 5 numbers and bam! The mean is 14. You can see on the chart how 14 is the balance point for all that data. Now, the mean is awesome if your data is nice and symmetrical, but it has one huge weakness. It's super sensitive to outliers, those 1 or 2 crazy extreme values. We'll see what that means in a second. Next up is our hero for messy data, the median. The median is simple. It's just the middle value. Step 1, sort all your numbers from smallest to largest. Step 2, pick the one right in the middle. If you have an even number, you just average the 2 middle ones. Now, look at this example, 10, 12, 14, 16, and then 90. That 90 is a crazy outlier, right? If we calculated the mean, it would be 28.4. That's not typical at all. But the median, it doesn't care. It just looks at the list and says, hey, 14 is still the one in the middle. This is why we use the median. It is resistant to outliers. It gives you a much better sense of the typical value when your data is skewed or has those weird extreme numbers. And our third tool is the mode. This one might be the easiest of all. It's just the value that shows up the most often, the most frequent, the most popular. Look at the data. Which number appears the most? It's 4. It shows up 3 times, so the mode is 4. Now, when would you use this? Imagine you're a company. You want to know the most popular t-shirt size to stock up on. You don't want the average size, you want the mode. It's perfect for categorical data, like favorite colors, shoe sizes, or yes-no votes. And anytime you just need to know what's the most common choice. Okay, let's put it all together. A quick review of our big three. You use the mean when your data is nice, symmetrical, no crazy outliers. It's the best for doing more math later. You use the median when your data is messy, when it's skewed or has outliers, like that 90 in our example. It gives you a more reliable middle. And you use the mode when you need to know what's most frequent or popular, especially with categorical data. 3 different tools for 3 different jobs. Let's see this in a real-world battle. A restaurant is tracking wait times. Look at the data. 10 minutes, 12, 12, 15, 18, 18, 18, 25. And then one poor person waited 60 minutes. Now, if the restaurant manager uses the mean, the average is 20.9 minutes. That 60-minute wait is inflating the number, making the restaurant look worse than it is. But what's the median? The middle value is 18 minutes. And the mode? The most common wait time is also 18 minutes. So if you were telling customers what to expect, what's the best choice? The median or the mode? They give a much better, more honest reflection of the typical customer experience. See? The tool you choose changes the story. Okay, so we know how to find the center of our data. We're done, right? Nope. Knowing the center is only half the story. We also need to know, what about the spread? Think about it. 2 data sets can have the exact same mean, but look totally different. Look at that graphic. Low variance means all the data points are tightly clustered together. Everyone's score is similar. High variance means the data is all over the place. This is where variance and standard deviation come in. They tell us about consistency and variability. Variance measures how far each number is from the mean. And standard deviation, which is just the square root of the variance, is amazing because it's expressed in the same units as the original data. This is critical for things like quality control or risk assessment. Let's look closer. So let's break down variance. The definition sounds scary. The average square deviation from the mean. But let's just look at the example. It's simple. We have website conversion rates. The mean, or average, is 2.96%. Now look at the table. We take each value, like 2.8%, and see how far it is from the mean. That's the error. 2.8 minus 2.96 is negative 0.16. Then we square that error to get rid of the negative signs. We do that for all the values. Add up all those squared errors and divide by the number of values. And we get variance equals 0.0082. Now, does that number mean anything to you? Not really, but it's a small number. And a small variance tells us something super important. All the data points are tightly clustered around the mean. This tells us the conversion rate is really consistent. That's the power of variance. But wait, that last number, variance equals 0.082, what does that even mean? It's not a percentage, it's not anything. It's in squared units, which is just weird. Meet the hero of this story, standard deviation. This is the super simple fix. We just take the square root of that weird variance number. Look at the example. The square root of 0.082 is 0.09%. Boom! Now that's a number we can use. It's in the same units as our original data. This is the practical interpretation right here. A low standard deviation, like 0.09%, means our data is super consistent. A high one would mean our data is all over the place. And check out that bell curve. For tons of data in the real world, about 68% of all your data points will fall within just one standard deviation of the mean. This is a huge idea. that tells us how normal our data spread is. So, to put it all together, variance finds the mess, and standard deviation cleans it up and puts it in units we can actually understand. And that is it. We have completed our quest. Let's do a super fast recap of the treasure we've unlocked. First, we learned the big three of central tendency. Mean, the average, but it's sensitive to outliers. Median, the middle value, and it's your best friend when you have skewed data or crazy outliers. Mode, the most popular choice. Then, we learned how to measure the spread. Variance tells us how spread out the data is. Standard deviation, the super useful one that translates that spread back into the original units so we can understand consistency. So, what's the key application? Why did we do this? Because you now have the power to transform raw, messy, boring data into meaningful insights. You know that choosing the right measure is critical to telling the right story. This isn't just theory. This is the foundation for all data analysis, and now you know how to apply it. Thank you so much for your attention and for joining this mission. Awesome job, everyone. I'll catch you in the next one.